everybody, Andy Walding here. Welcome to my presentation on troubleshooting voice using Wireshark. This is an essential skill, and I want to talk about it. I want to give you some demonstrations to this. Let's go to the share here so that we can take a look at my presentation. There we go. All right, so for those of you who are not familiar with what has happened, and I'm sure it's very few of you, voice, the traditional voice in the network has gone from lines and so forth to now packet voice. Now, the thing that we have in common between today's voice over IP and the prior digital voice with digital switches and so forth is that we're converting voice to ones and zeros. The difference is that now we involve server functions that packetize this voice and then use the internet to send this voice out to whoever we're calling. This is a little bit more in depth. It's a little bit more distributed than it used to be. There's a lot of systems that come into play. And it's really important that we understand a lot of things can go wrong. The telephone handsets are not just dumb handsets anymore. They're intelligent, they're computers, and they use packets to communicate back to these servers. Okay, so before we jump in, just a couple of things. There is a link right here to a PDF of this presentation. So if you want to download the slides and all the references that I'm going to make, please feel free to do so. Again, there's the link right there. And they may attach a version of this link somewhere as well. All right. With that said, a little introduction on me. You can read more about me in my bio right here. I have 5 patents in telecommunications. I hold multiple certifications. I founded Cellstream back in 1998 and the Online School of Network Sciences in 2013. I've been a ethereal Wireshark TCP dump evangelist since 1998 for sure, and probably before that actually. I've also been a researcher. There's lots of publications. I've been a teacher. I've taught a lot of technologies over the years. You can follow any of these links to my Twitter, YouTube, LinkedIn. On YouTube, there's a lot of example uses of Wireshark and so forth. I encourage you to look. So that's a little bit about me. Let's get into what we're going to do here. Now, the goals and objectives of this presentation is to take about 45 minutes, maybe a little bit less, make this an interactive and educational session for you. I'll be discussing and demonstrating how we can find issues with IP telephony, and I'll do this by examining several real-world packet captures. Again, this type of troubleshooting is an essential skill in today's packet-based telephone networks. Now, I'm going to use a tool called Wireshark, and you will see how troubleshooting is done with Wireshark. If you're not familiar with Wireshark, let me give you a little view of what Wireshark is and what it does.
Okay, let's start up Wireshark here. So this is what Wireshark looks like when you first open it up. Basically, any prior files you've opened will be listed here, and then all of the interfaces on the computer that the technician is using are then shown here. Now, right now I'm running on Ethernet, and I can select the Ethernet interface, and I can tell Wireshark to start capturing the packets that are on that interface. And you can see that's literally happening right now. So these are all of the packets that are going in and out of my computer onto the internet. Okay, and we're capturing these into memory. Now I can stop the capture, and then I can go and look at these packets. That's what Wireshark is all about. I can simply go up here, scroll back up. I can pick one of the packets like this one, packet number 47. You can see that this tool then dissects this information. I can see that it is the internet protocol. I can look at the internet protocol information. In this case, it's transporting TCP. I can see its information, and this is all running over Ethernet, and I can see the header information for Ethernet. So this is a great way to capture, visualize, and then dissect whatever is being sent between these devices on an internet connection. That's the whole idea of Wireshark. It's just a very brief overview. And I will be using this tool. Let me close this. I'm going to be using this tool here to then explain some of these voice over IP concepts with you. Okay, let's go back to the slides here. So if you're interested in where you would get this free tool, you can find it right here at www.wireshark.org. That's where you can download it and install it for Windows, for Mac, for Linux, whatever platform you're using, Wireshark will run on that platform. Now, a couple of environmental details. For those of you who are familiar with Wireshark, Wireshark comes with what's called a default profile, and that's the way that Wireshark looks and feels and how it looks on the screen. I am going to change this to use different profiles. I have voice over IP profiles, I have IPv6 profiles, et cetera, et cetera. I'm going to change the profile so that I can customize how Wireshark looks and feels, and in particular, tune it to voice and voice packets. Now, you can grab any of the profiles that I'm going to use, as well as a whole bunch of others, at this link right here. This is a profile repository. There's a video link there on how to use profiles and so forth. It's completely free, and I vet all of these profiles. I'm the only person that can post there. So please feel free to grab them and increase your productivity with Wireshark by customizing how it works. The one thing I can't share with you is the packet captures, and I apologize for that. I'm sorry about that. These are real packet captures from real networks, and therefore they contain intellectual property of the people who were using these telephones and so forth. So I can't share that with you, but all of the profiles are readily available. Okay, with that said, let's get into my first demonstration. I title this, What's Wrong with the Phone? So this is a problem of the phone not initializing, and let's get in and take a look at this. Okay, let's begin by opening up the capture file that I was sent, and it's this one right here. There we go. Now, for those of you who use Wireshark, as I said before, I'm not in my default profile. I'm using something called a better default. It adds some time delta information to show me what's going on, as well as some other things that I can do, and some more vivid colors. So I just think it stands out a little bit more. So let's talk a little bit about what's going on in this packet capture. Now, when I get a packet capture, I can't really understand everything. They just send me the packet capture and they say, tell us what's going on. So I have to begin my troubleshooting at very basic steps, and I follow a rigorous troubleshooting process. One of the things that I always do is I click on this little dot down here to get a report on what is happening. So Wireshark is telling me here that I have warnings, okay? And if I expand this a little bit, you can see that this is quite repetitive, that we're getting some sort of error code here from something called TFTP, Trivial File Transfer Protocol. So this gives me a little clue as to what could be going wrong. Now, this isn't always successful, but I always check this as sort of my first step. And in this case, it's starting to hint to me, right, what is going on. Now, I'm sure the people that sent this to me did not do this, and otherwise they would have pretty much, I think, been able to figure it out quite quickly. All right, so I've got an idea, and that gives me, sort of a path that I may want to follow. So I'm starting at the beginning here with the first packet right here at time 0, and we can see that a 192.168.111.112 address is sending a read request to 172.23.12.85. This must be some sort of server or something like that. And we can see that Wireshark is saying that this is a read request for this configuration file. So, okay, pretty interesting. As I look at this, at the details of this down here, all of the packet communications is sort of like a layered cake. We have layer 1, layer 2, layer 3, layer 4, and layer 5. That's typically how these packets are built by the communications protocol stacks. And so we see basically that this is an Ethernet frame carrying IPv4, carrying UDP, carrying a protocol called TFTP. And if you'll recall from what I just did down here with the little dot is we had some TFTP errors. Okay, so I'm seeing this, what's called read request for that source file. Okay, so awesome. Now, just before I do my next step, I do notice that in the very next packet that server or whatever this is at 172.23.12.85, I have to presume it's a server, or it could be a phone switch or something like that, that this has actually sent an acknowledgement back. So the good news here is that the phone seems to be asking for its configuration file from the server, which is really, really good news. Now, because this is using TFTP, and as I just quickly sort of scan through here, I see more and more TFTP. Each one of these packets is really TFTP. What I'm going to do is I'm going to switch to my TFTP profile, okay? So I'm just basically telling Wireshark here, switch to TFTP. And when I do this, it sort of gives me a little bit different view of the same information. These are the same packets, but the colorization has changed for me. I'm also getting a diagram of these packets and what's going on. That's really nice. So this gives me a great ability to now sort of read through what's happening a little bit better. Okay, so there's our read request like we saw before. I can actually make this a little bit bigger, okay? And then we see an acknowledgement, okay? And then we see yet another acknowledgement back. So it's very clear here that the phone is talking to the switch or to the server, and that's good. In fact, it's also good to see that we indeed have received this configuration file, because there's the data packet with all the data. So we got this configuration file. Now, we don't necessarily know what's inside this configuration file, whether this information is accurate or not. You'd have to understand, how this particular phone system works and so forth. I don't necessarily need to know that to be able to continue on. So all of this happened in about 37 milliseconds, okay? And then what we see is the phone now goes out and it says to the server, hey, I want this SIP configuration file right here, okay? And there's a name of this file. So our basic configuration told us that we need this SIP configuration. Now, if you're not familiar with Wireshark or with Voice over IP, I'll show you what SIP looks like in just a few minutes, but SIP is the signaling protocol of Voice over IP. So this is how you make calls and you answer calls and so forth. I'll show you how that works in a little bit. But this is basically a configuration file of how we will use SIP and how we behave on the network. What I then notice, and it's standing out to me in red here because it has an error code. Okay, now you're probably all familiar with error codes, right? You've probably seen things like 404 errors and so forth. That's very common when you're using what's called HTTP, Hypertext Transfer Protocol. So we're seeing an error code here as the phone tries to download the SIP configuration. And then what we see is it sort of tries again, and yet again, we get another error, okay? Then we see that the phone tries to download some sort of development config. Now, this is probably built in by the equipment manufacturer for, if the configuration, the base configuration file doesn't load, you go get this development configuration file, which has some basic information to at least get the phone to come up and be running. And it looks like that worked, which then gave the phone some other configurations like your phone, the web, the license, and so forth, all the licensing information, the directory information. But we can see none of these actually exist. So whoever's running this system, while the dev config file is there, they actually don't have this sort of base configuration set up on their system, which is, by the way, very normal, okay? So what's really happened, right? If we step back from this, what really happened here, and I think it jumps out at us, is this configuration file, this 004 F2 809 F0A config file does exist. So whoever set this phone system up, that is there. However, its SIP configuration is not there. And sure enough, right, they were able to go back and they were like, let's take a look. And they found out, right, this is what the phone was looking for. And they had a typo in here. They had a number transposed or something like that. So this part of the configuration was misconfigured, and therefore the phone was not able to download its correct configuration and continue on with its boot process, okay? And then all of this other stuff, which I think they found to be very distracting, was really meaningless, and it didn't really matter. You know, they thought it was missing its license or that the license wasn't valid. They ran off on all sorts of different directions, when the truth is, all that they needed to do was fix that SIP configuration file. Now, I don't have the part where it worked, obviously, because they then fixed this and the phone worked and everything was fine. So this is a great sort of first example that Wireshark can become so powerful to help technicians and CO technicians and engineers, find out exactly what is going on. And again, the key is to make this easy to view and easy to understand, because there's a lot of technical data here. All right, so that's my first demonstration. What I'd like to do now is provide a little reference to some of these other operations like the SIP signaling, and then we'll get into the second demonstration. Okay, going back to my slides. So this is an example, this is what we call a ladder diagram of how the SIP protocol works, right? How voice over IP really works. So assuming that the phone has initialized properly, which is what our last demonstration showed it didn't, but assuming it does, it becomes a member of the network. It becomes a valid extension or phone number, connected to the voice switch, okay? And then if somebody picks up the receiver and dials a number, what's going to happen is the SIP protocol, which we were talking about just a moment ago, is going to send out an invite. That invite then goes out to whoever the dialed party is. We get messages coming back. We get, notice a message that says, hey, play the ringing sound, right? So the ring doesn't come from the switch. It's just a command that comes out to the phone that says, play a ring in the earpiece, right? So we would expect to see this. And then we see these OK messages and then acknowledgments. And we sort of saw that in the prior capture, that this is our way of knowing that these devices are properly communicating. And if all of this is acknowledged, we then end up in what's called a media session. Now, this does not use SIP. This media session of actually sending the voice this way and the voice coming back the other way, this is all done with a different protocol. It's called RTP, real-time protocol, and its sister called RTCP, okay? So this is the bidirectional voice here that is actually going back and forth between the two devices or the two phones. And then once somebody hangs up, we get a bye, and then we get an OK that says, yes, I got the bye. So you can tell who hung up on who, that type of thing, by watching which direction these occur in. So there's two parts to this voice over IP world, right? There's this control plane, if you will, where we're sending these control messages, and then there is the data plane, which is actually the media session, okay? Sometimes we end up troubleshooting the control plane, and other times we end up troubleshooting the actual data plane, the actual voice itself. So in this next demonstration, I'm going to focus on the control plane, right? The SIP information. Now, generally, you have to have some sort of cheat sheet for all of this. This is our SIP response message cheat sheet, and I use this all the time. I have it printed out, and it's near me at all times. And you can see this is heavily based in, what we're used to in the web world, right? Where you get that 200 OK and the 404 message, right? Not found. I mean, you've seen these in hypertext transfer protocol. They basically cut and pasted all of those things into this voice over IP world. So of course they expanded on it for all the different possible errors, but you can see that client failure errors are in the 400s. Server failures are in the 500s. Global failures are in the 600s. And then, of course, those 200s are generally mean that everything is okay. So if we have Wireshark, what we would want to do is we're going to see these SIP messages once the phone is working properly, and we should be able to decode these messages, maybe colorize them, right? Maybe you want to see the error messages as being red or orange or something like that. Okay, so knowing that as a little bit of a backdrop, and I know this is a lot of information, but knowing that, let's go in to our second demo. Now, the issue here is what's wrong with Casey's phone. All right, let's take a look. Okay, coming back over here to my Wireshark, I've closed the prior file and I've switched back to my better default profile, okay? And let's open up this one. Okay, so once again, I have a packet capture. I really don't know, other than somebody's phone called Casey is apparently not working. All right, same sort of process. I'm going to look here at the information that the Wireshark expert provides us, and we see some warnings, connection reset. Okay, I mean, nothing super crazy here. So in this particular case, this really did not help me, which is in a way still good news, right? So, okay, fine. I'm going to close that out. So again, the problem is that Casey is not able to make calls. Now, the other thing that they told me was that he is able to receive outside calls. Very interesting. All right, so would you suspect the control plane, meaning SIP, or would you suspect the data plane, meaning RTP? I'll give you just a moment to think about that. If you're with me, I think that I first would start with looking at the control plane here. Now, there's a whole bunch of packets in here. If I scroll all the way down very quickly, oh my gosh, right? 1,355 packets. So what I want to do now is change the configuration of Wireshark to use SIP, to focus on SIP. So I'm going to go here, and I have a SIP profile right here, and I'm going to switch to that SIP profile. Now, it's a little bit harder to see because there's a lot more information. Now, remember, all I've done is change the look and feel of Wireshark, okay? So columns have changed, okay? Colors have changed. But other than that, we're still dealing with the exact same packet capture. It's just different how we see it, okay? So now that I have done this, right, I want to, because I'm suspecting there's something going on with SIP here, what I want to do is see the SIP information. And notice right here is a little button that I can filter for just the SIP packet. So I'm going to click on that. All right, so what's happened here is we are only looking at SIP. We're not looking at any other type of traffic. We're just focused on the SIP traffic. So basically, so far I've clicked, what, 3 things, and I've been immediately able to zoom in to what is going on with SIP, okay? And I suddenly see a repetitive pattern. You can see green, orange, green, orange, green, orange, green, orange, right? And look at this, SIP is painting those 401 errors as orange, and everything else sort of isn't, right? It's green or green and blue or green and black or something like that. So this helps me now to focus myself on what is going on. The second thing that I notice is, look at this, Casey Zimmerman, aha, right? So this matches exactly what I was told was the problem, okay? So let's take a look at these sort of one by one. We'll start here. The first packet that contains SIP information is packet number 648, and we see this is SIP, right? Again, we see that layered cake right here, and we see a request to register, okay? So this is registering with the phone at this network. The next packet is, we see a status code 100, which is trying. And if you think back to that slide I showed before, this actually makes sense. This is the way it's supposed to work. So we're seeing the trying message. This is a good message. And again, the good news here is the phone and the switch are talking to one another, which is good. All of these IP addresses are correct. I'm feeling good so far. Then we move on to the next step in this, and we see 401. That's an error code, right? Unauthorized. Okay, unauthorized. And basically, now I can sort of say, all right, I sort of see this repetitive process, right? So here we see Casey going out, registering once again. I then see the 100 it's trying. And then I see a status code, okay. Okay, wait a minute. So it appears that part of this registration is working, okay? And then again, tries to register, okay, trying, and then failure. Okay, so it seems that part of the registration is occurring properly and the rest of it is not. So this would make sense, right? This would make sense to the reported problem. Remember, he was able to receive calls from outside, but wasn't able to make any calls. And so right there is the exact problem, right? Now, how was I able to get here so quickly? Part of it is knowing how the protocol works a little bit, yes, but I don't need to know a lot about that. What I needed to do was customize Wireshark so that we can get very quickly at what the issues are, right? And visualize what's going on, filtering out all the other noise so that we can drill down and start to see what's going on. And then basically after that, I sort of see this process repeating itself, right? As I scroll down, you can just see it's just a repetitive cycle of the same thing over and over and over. So the answer to this is that the SIP configuration that Casey Zimmerman's phone has is not completely correct. Part of it is there and part of it is correct, but the rest is not. So once again, this just comes down to configuration, and we now understand exactly where we need to dig in. We need to dig into that SIP configuration file for this particular extension or user and fix that so that this phone can reinitialize with the correct information. And then we would see all of this work fine and the phone would work fine. Okay. So again, just being able to drill down quickly here, looking at the control plane, looking at the SIP messaging, and then decoding this messaging got us to where the problem was very, very quickly. And this is, again, just such a powerful thing within Wireshark. Now, within this profile, we've got other things. We can just filter for SIP errors, right? There they are. I mean, this is another thing that maybe I would do, right? Let's say I had this huge packet capture and there are hundreds of people in this call center and there's all kinds of SIP messaging. I mean, it wouldn't be so easy to see this, right? So luckily the people who sent this to me were capturing at the point where they were just looking at Casey's phone. But I would maybe use this filter here to find these error messages and be able to, once again, just sort of drill down very quickly. Also things like wrong ports. Now notice there are no issues here, right? When I filtered for wrong port, I get no packets. That's good news. It means everything's okay. You know, are we getting registrations? Yes, we are. There they are, right there. And you can see kind of the issue here, right? So Casey's outside phone number was registering okay, but it's that extension number within the VoIP system, that's where the issues were. So that, again, helps me to see that pretty quickly. There was no authorization issues, and I don't have any packets with comments. Sometimes when you're troubleshooting this, right, you as you go through, you can right-click on this, and you can add a packet comment to the actual packet capture. And this is very helpful for passing information on to another person, another teammate, or creating a customer record, if you will, of what we found when we did the troubleshooting. And then you can just filter for those packet comments so that you can quickly go and look at that stuff. Again, very, very powerful if you configure Wireshark this way. So hopefully that helps you to see exactly how SIP works and how powerful Wireshark can be with SIP. Let's move on to the next demonstration. Okay, our next demonstration is going to be titled, What's Wrong with Vonda's Phone? Okay, so different issue here. Let's take a look at the packet capture. Okay, so I'm back on Wireshark. Let's close that prior capture file, and we will open up the next demonstration. Notice that I am still in my SIP profile, okay? So I'm still filtering for SIP like I did on the prior one. We've just now got a different capture file open. All right, so what could be going on? Now, the reported problem is that Vonda is not able to make calls, but can receive calls, okay? So let's clear this filter for a second and just go to the top of the packet capture. Okay, fine. I'm just sort of getting my head around what's going on here. All the way down, there's again over 1,100 packets in this packet capture. All right, there's a lot of other traffic in here. So again, I like to filter for SIP. All right, so we're back here, and sure enough, there's Vonda Kirby right there. Now, in this case, I want to just zoom in because there could be other people in here. So to focus on Vonda Kirby specifically, what we're going to do is add for just her IP address, okay? So if I look here, Vonda Kirby appears to be at 192.168.50.89. Okay, so let's try this. Let's try to manually ip.addr equals, and then 192.168.50.89. So in this case now, what I'm doing is I am just filtering for all the traffic from that particular IP address. Now, it's going to include SIP information, but I want to see what else is going on here, okay? So it looks like it did DNS. It looks like it did some TCP traffic. Okay. So this is probably right here is probably where it's grabbing its configuration. Okay. And some stuff is being transferred. So all of that looks good. There was a little reset here that occurs with that. Okay. Not terribly concerned with that. Sometimes, when something is done, it doesn't say I'm done. It just sort of sits there. And so, okay, that's not terribly concerning. But it does seem to grab all of this configuration. And then once that's done, kind of like we saw before, we see a register, okay? So we get the trying, and then we get, oh, look at that, a very similar issue, right? We see that what's happening is that it is unauthorized, okay? And then there's another attempt. This time it says trying, and this time it says okay. All right. And you can see that there was a binding done. So part of this configuration seems to be working, okay? And part of it does not, okay? And that process, again, appears to sort of repeat itself. Now, again, I'm not too concerned with these resets. Somebody could have unplugged or plugged the phone in, or was trying to do something with the phone, and it just caused those TCP issues to occur. Again, not too terribly concerned. I do see this process sort of repeating. Now wait a minute. As we go down here a little bit further, we can see, okay, so somebody was trying to fix something here, and okay, so there's the outside telephone number, and we're getting the 200 OKs. This is good. But then when it tries to register the extension 4956, again, we're getting unauthorized, right? It said, okay, let's subscribe, gets 202. All right, there's the phone number. That's all fine. And then when it tries to subscribe, again, we get not authorized. So again, this all appears to be in the control plane configuration side of things for Vonda Kirby. We're just not properly configured here, either on the switch, well, it is on the switch, or in some server that these configuration files are not properly, the contents aren't proper, so that when the phone goes through this process, it's stumbling. Now it's almost there, okay? It's almost there. And it looks like they were onto this because they did get it to sort of start to work, but it didn't get all the way through. So once again, right, the answer to this is let's go back into those configuration files. Let's triple check everything because there must be a typo. There must be something that doesn't match the database accurately, and it's stopping this phone from properly working. Okay, so that process seems to repeat itself. And, again, pretty straightforward. So again, you can do this by just looking at SIP. You can do this by then actually filtering for a particular device or for a particular address, which will give you, the context of these SIP messages along with everything else that's going on, right? As I go back up here, we see, that we were downloading this configuration and so forth. We see that it's talking to the DNS and getting the name server information. So, and that's another place that this could go wrong, right? Is that the name server information is wrong. So all of this is readily available to us by using Wireshark and should have resulted in this being fixed very quickly rather than what it really took. Okay, so hopefully that helps you with another sort of view of SIP. Let's move on to the next demo. But before I do, I want to show you one other cool thing in Wireshark that Wireshark does with telephony. Now, it has an entire telephony dropdown here. Okay, a lot of people ask me, like, how can you find calls? It's really simple, and we'll be doing that in the next demo. But the other thing that we have is we have a whole bunch of statistics, like SIP statistics. Look at this. So I can quickly, just by clicking that, I'll expand it a little bit here. I can quickly look, right? Are there any messages, and how many of them are there? Like there's, right, the transaction does not exist. That's an error message. Remember, the 400s are error messages, right? There were 19 of these unauthorized messages. There were 17 accepted, 37 OKs, right? I mean, this is another quick way to sort of look at the statistical performance. Now, in a working situation, you then have setup times, right? How long is it taking from somebody picking up the receiver and then dialing a number and having all of this process work? You can see that we get average setup, minimum setup times, and so forth. If we had working phones, we would see that these numbers would contain actual information. So again, knowing that the system is working within what a human would consider comfortable. And this is all built right into Wireshark. So it's a great way to understand whether the phone system is working within spec. So I just wanted to quickly show that. Okay, let's move on to our next demo. All right, in this next demonstration, demo number 4, I'm going to look at an actual call. Now, this is a good call and it's going to work, but I think that's really important to be able to see this process within Wireshark. All right, let's take a look. Okay, let's close that prior capture file and let's open up this call. Now, again, I am still in my NetSci SIP profile, and I have a filter which is actually preventing me from seeing anything. So let me clear the filter. There we go. All right. So I'm in the SIP profile, and we can certainly filter for SIP. And here's, oh, look at this, everything, right? There's no red whatsoever, right? No orange. So this clearly indicates that the signaling part of whatever is in this capture file appears to be working fine. And I sort of can see this. I see an invite, I see trying, I see ringing, aha, okay, right? And then I see a bye and an okay. And then, so there are several calls in here. They're all, clearly seen from just filtering for SIP, okay? So if I click on SIP errors, there are none, okay? All right, so very, very good. Now, what are these calls? How can I find these calls? There are several things that make this really, really easy in Wireshark. I get this all the time from CO techs. They go, I've done a capture on this port on this VLAN, and oh my gosh, there's so much internet traffic. How do I find the phone calls? The answer is we go to telephony and we say VoIP calls, okay? And we get a pop-up that looks like this. And you can see here that Wireshark has told us these are the calls, okay? This is all the stuff. So I can literally simply select a call and I can say, prepare a filter for this, and then I can close this, all right? And look, we've got the SIP signaling, that's the control plane. And then, ooh, look, I've got RTP. So this is the actual data going back and forth between the calling party and the called party, okay? Those are their IP addresses. So this is the RTP traffic. How cool is that? So in literally just a couple of clicks, I was able to find one of these calls and to filter that call out of all the other packets. And out of 6,486 packets, we're displaying 2,074 just simply by doing this. So it's super, super, super easy. All right, let's go back. I'll do that one more time. So telephony VoIP calls, there's the list. Okay, now what if I would like to understand, what this call sounded like? Okay, so check this out. I can say play streams, and there we go. Okay, so what does Wireshark just done? What it's done is it's taken those RTP packets, it has unloaded, taken the information out, which you can see back in the background here. It says it's G711 traffic, and it has actually run a decoder, and it's given us the traffic right here. And we can see the two sides of the conversation. We see one here and then this one here, okay? So you can actually play this. I don't think you'll be able to hear it, but I'll just push play so you can see. If you can hear this, that's great. If not, don't worry about it. But basically you have somebody talking here, a beep, and then somebody talking. So this is someone basically leaving a voicemail for somebody else, okay? So pretty cool, right, that we can do all of that, all right, within Wireshark. Another thing that we can do is, let's close this, okay, is we can go to the telephony and we can take a look at the SIP traffic. Let me do it this way. I'm going to actually go here, and I'm going to change profiles to RTP, and there we go. All right, so now I'm just looking at the RTP. Well, you can see the invite and so forth, but then the RTP right here. And I can do a couple of things, right? So first I can just filter for RTP. I could maybe look at, are there any packets that are greater than 125 microseconds, okay, where time has passed greater than that? With G711, it's simple mathematics as to how often I should see packets. And the good news here is I see no packets, right? So again, back to RTP, I can now select the first packet, go to telephony, and go to RTP and do a stream analysis. Okay, here we go. So this is the RTP performance, if you will. Okay, so we see that sequence numbers are correct. Every packet has a sequence number. We see the time deltas should be right around 20 milliseconds, right? And you can see that's very consistent because that's how often a packet comes out of a G711 codec. We can see the jitter. Again, we're looking for jitter to be fairly consistent. And then how much bandwidth, right? So all of this information or performance is being analyzed by Wireshark. Now, this goes on and on throughout the calls, but you can see a summary here from one to the other of its performance, okay? So really, really cool. Any sequence errors? Nope. Any packets lost? Nope, right? So very, very good. This is looking very good. If there were any kind of issues here in the RTP traffic, like for instance, packets being dropped, somebody may or may not be able to detect that in their ears, but we would see this almost right away, right? Right away. And then we would be able to say, okay, why are these packets getting dropped? Is that port on that switch overloaded, right? What's the bandwidth consumption, right? It can lead to other discovery that we would do taking a look at, the network, as it were, right? Based on this information. So again, very, very quickly, just to review, right? Now, this is a good call, so there was nothing to troubleshoot here. And I've proven this, right? I'm proving by looking at statistics, by filtering what I'm looking at, I get a very quick view of what is going on with voice over IP. This time, of course, in the data plane with the RTP rather than the SIP. So pretty cool, right? Again, all of this is built into Wireshark. There's no special licenses. It's all free. I'm sounding like a little commercial for Wireshark, but if you're not using this to analyze your voice over IP traffic, you're missing, right? You're missing out. This is really, really important.
All right, let's go back to the slides. So when you're troubleshooting voice over IP, there's sort of this high level approach that you need to take, right? You have to have a plan. You need a configuration or a set of configurations for Wireshark, like these profiles that I was talking about. And you also need to know, of course, where you should capture and how you will track this evidence. To me, it's all about capturing this and creating a record, an evidence of exactly what happened. And then you can add annotations to the packets and so forth, but you create a record, right? And then you can then share it with somebody, you can explain it to a customer, whatever, okay? Once you have the plan and you know what you're going to do, you can actually then go and perform the capture and then, of course, analyze this. And you might have to possibly iterate. You might have to do this over and over and over again in order to get it right so that you can get the stuff that you're needing to look at. Again, to me, it's like this picture right here on the slide, right? It's like a crime scene. You can't reboot things, okay? So many times people reboot, they power cycle. Now, I know that that works some of the time, but really, this is about evidence gathering. Evidence gathering is really troubleshooting, right? And I love this little statement here: the absence of evidence is not the evidence of absence. Very, very important. So you have to build a process that makes sense to you, the individual technician or the engineer or whatever, right? And you saw me, I sort of do this. I mean, I always start with that expert info analysis, okay? I look at things like statistics, graphs. This is really, really important to visualize. Humans, we're visual people. You show me a picture of what it looks like, and that sticks in my head. I can start to do analysis. Looking for things like delta times. How much time is passing between each of these events? Remember, this happens very quickly, so therefore those delta times need to be consistent. Then you start looking at this layered cake, right? Layer 3, which is IP with things like QoS. Is the DNS working? Do we have ICMP errors? Those sorts of things. I didn't show examples of that, but these are all part of that checklist, just like a pilot would have a checklist that they would verify that the plane is working okay. Or if there's a problem, what should they look at? SIP, the control plane of voice over IP. Are the calls being requested properly? Are they able to authorize? Do they have the right configuration files? Are there any errors in this process? Are they using the right port numbers? I didn't show any examples of this, but often configuration will have the wrong port number. And if you have the wrong port number in this protocol stack, you're not going to communicate properly. So again, comparing that to that communications ladder that was in one of my earlier slides. And then the data plane, RTP, right? RTCP. Do we have those 20 millisecond delta times? Are sequence numbers correct? Looking at the statistics, is all of this working within an acceptable margin, an acceptable performance margin that customers are going to be happy with, that users are going to be experiencing good performance? So all of these things are part of this more or less continual troubleshooting process. And you have to make a process that makes sense to your brain. This is my process. I'm just offering it to you. And then, of course, you would modify this process as necessary. All right, I'm running out of time, but there's a lot of resources. Obviously, Wireshark itself has where you can get the packet analyzer and all of that. I've given you a link once again to the profiles repository. There's the main CellStream website. There's a lot of stuff that I publish on there. I encourage you to read articles, do searches, and so forth. We have a lot of training classes on this to give you firsthand experience, lead you through labs and so on. They're all hands-on. Some are available in Zoom. Others are available in person. Again, there's a link to our courses. Please check it out. We'd love to see you in a class and kind of elevate your skill level. Lots of tips and tricks, cheat sheets, other interesting reading. There's our online school. Feel free to go there as well. It's free to create a user. There's a lot of free information there. Please check it out. Please check it out. Also, whenever I publish new profiles or update profiles and so forth, I always notify on Twitter. So feel free to follow me on Twitter. Now, if there's a way for you to get a hold of me, please feel free to do that. I'll be glad to take any questions and get back to you with answers. I hope you got a good view of what this is all about. Thanks for watching, and I hope to see you again soon.